So hello and welcome everyone to the 7th video of the digital electronics. This is the part 4 of the number system conversion. In the last part 3 we have done the various conversions. If you have not seen those videos, you can check out the videos. The link might be flashing over here in the I button, so you can go there and you can check out. Now let's come back to this video. What we are going to do in this video is the continuation of the number system conversion. But here what we will do is we will do the conversion from hexadecimal number system to the binary and from binary to hexadecimal number system. In the hexadecimal, the key is we just need to write down the decimal equivalent in the group of 4 bits. So for this conversion, you need to remember the binary from 0 to 15. Okay, from 0 to 15. And if you don't remember the binary from 0 to 15, I have also given you the shortcut trick, 8421 trick I have given you in the first video, in the first or second video. So you can also check out those videos of this playlist only. So now let's start with the example. So the first example that we will take is we have the hexadecimal number, that is ABCD. Okay, this is not the movie, this is the number, hexadecimal number ABCD that we want to convert into the binary. Okay, so the simple thing we will do, we will first write down each and every digit that we are having in the hexadecimal number. Now for each and every digit, for each and every hexadecimal digit, we need to write down the binary. Okay, we need to write down the binary in the group of 4 bits. Now here we all know that A represents 10, B represents 11, C represents 12, and D represents 13, right? So basically we need to write down the binary of 10, 11, 12, and 13 in the group of 4 bits. Here by itself we will get the group of 4 bits. So for 13, if you simply write down, so here you need to remember what is the binary of the 13. So that is why I told you, you need to by heart the binary from 0 to 15. And for that also I have given you the shortcut trick, that is 8421 trick. So simply here the binary of 13 is 1101, right? 8 plus 4 is 12, 12 plus 1 is 13. The binary of 12 is 1100, binary of 11 is 1011, and binary of 10 is 1010. Okay, and if you do this, your conversion is over. This is the binary number, this is the binary conversion of ABCD. Isn't it very simple? Now let's take another example. So this is what you need to do in the conversion from hexadecimal to binary. For each and every hexadecimal digit, you need to write down its binary in the group of 4 bits. Okay, let's take the next number. Now let's take one rational number, that is 13A.7b. Okay, this is my hexadecimal number and that I want to convert to the binary number. Okay, so first of all I will write down all the hexadecimal digit 13A.7b. Now for each and every digit I need to write down its binary equivalent into the group of 4 bits. Okay, so for A we know that it is 10 and the binary of 10 is 1010. Okay, the binary of 3 is 11, but we need to write down in the group of 4 bits. So we will add 2 zeros so that we will get 4 digits over here. So 0011, and for 1 it is only 1. We will add 3 zeros, so we will get the group of 4 bits for binary. Now what is here? Here we are having point, and after that we have 7. So the binary of 7 is 111, but again we need in the group of 4 bits, so 0 we will add over here, and B simply represents 11. So the binary of B or 11 is 1011. Now this is your complete conversion from hexadecimal to binary. So your answer is, see here in the first digit we can ignore these 3 zeros because it doesn't add any value, right? So 10011 1010.0111 So this will become the binary of the hexadecimal number 13A.7b. I hope with these 2 examples you were able to understand how to do the conversion from hexadecimal to binary. Now let's do the reversal. Let's take any binary number and do the conversion to the hexadecimal. Okay, so randomly I will take one number. Let's say 11001111000101. Okay, this is what we are taking. Now if we have any binary number, what we need to do is we simply need to make the group of 4 digits from the left. Okay, so from the left we will make the group of 4 digits. So this will become our first group, that is nothing but 0101. The next group is this, that is 1110, and the next group is this, that is 1001, and at the last we are having 1. So I will write 1 over here by itself. Okay, now after making all these groups we need to write down its decimal equivalent. Okay, so the 101's decimal will be 5. 1110, okay, 1110 means 14, and 14 is basically represented by E in the hexadecimal. 1001 is 9, and 1 simply is 1. Okay, so this is your hexadecimal conversion. Okay, so hexadecimal conversion of this binary number is 19E5. Isn't it very simple? The trick over here is we just need to make the group of 4 digits from the left, and after making the groups we need to write down its decimal equivalent, and once we do that our conversion is over. Now let's take one rational number, and with that also we'll do the same process. Randomly I will take any okay, this number I'm taking. Now what we need to do is the number that we are having before the point and the number we are having after the point. So we will do the same thing over here. We will make the group of 4 digits from the left side for the number that is before the point, but for the number that is after the point we will make the group of 4 digits from the right side. Okay, so this thing we will do. So first let's do the groups for the number that is before the point. Okay, so this is one group, right? 0 1 1 1 we will write over here, and the next group is this, that is 1 0 1 1. This is the second group. Okay, that we have done. Now we need to make the group for the number that is after the point from the right side. Okay, so from this manner we will make the group. So our first group will be 1 0 1 0, and the second group will be 1 1 0 1. And by chance if we were having only 1 over here, let's say this is the number, so this we will write, okay, 1 we will write, and here we will add 3 zeros, right? So this is how you need to make the groups. Fine. So now if we do the conversion, we need to write down the decimal equivalent of this binary. Okay, we need to write down the decimal equivalent of this binary. So 0 1 1 1 means 7, 1 0 1 1 means 11, and 11 means B in hexadecimal. Okay, 1 0 1 0 means 10, and 10 is represented by A. 1 1 0 1. Okay, 8 plus 4 12, 12 plus 1 13, 13 is represented by D. 1 0 0 is 8. Okay, so this is your hexadecimal number, B7.AD8. This is the hexadecimal of this binary number. Fine. I hope with these two examples you were able to understand how to do the conversion from binary to hexadecimal, and with this we came to the end of this video. Fine, so with that let's end the video and we will meet in the next video. Thank you very much.